Good morning again. Here is lesson 6.5 part 2, and let's get ready to start it. So in this lesson, we're just continuing on what you've learned in linear equalities. So if you remember, a linear equality is basically like a linear equation. You put a line on a graph, but the difference with linear inequality is after you put the line on the graph, you have to determine is it a dotted line because of it being an open inequality, or a solid line if it's a closed inequality. And you shade one side of the coordinate plane, where the line that you put is actually the border line. Now, how I taught you to find that line before was to use a test point, usually the point 0, 0, provided that it's not on the line, and put it into the inequality. The inequality makes a true statement, shade that side. If it makes a false statement, shade the other side. So this lesson, the primary thing that I wanted to teach you is there's a shortcut to that process, okay? First I want to say this. With your linear inequality, it should be written in slope-intercept form, which, as you remember, is y is equal to mx plus b, except with an inequality symbol instead of an equal sign. So here's the shortcut. If y is greater than or equal to mx plus b, or if y is greater than mx plus b, then shade above the line, okay? If y is less than or equal to mx plus b, or less than mx plus b, then shade below the line, okay? So it's actually just as simple as that. And I'm just going to do a sample one. I'm just going to make a coordinate plane. I'm not even going to make an actual equation. I'm just going to go ahead and toss a line on here. Okay? So, if y is greater than, you would shade the above part. If y is less than, you would shade the below part. Now, provided that your line is not completely vertical, like I just made my highlighter here vertical, but if it has any amount of slant to it whatsoever, no matter which direction the slant is going, the top part of the line is shaded if your inequality has an above statement. The bottom part of the line is shaded if your inequality has a below statement when it's written in slope-intercept form. Now, I wrote to view problem 4 in the book and problem 5. I was going to write them out, but they are kind of lengthy, and I just felt like I wanted to get this video out pretty soon. Okay, so let's take a look here. Here's problem 4. So problem 4 says, an interior decorator is going to remodel a kitchen. The wall above the stove and the counter is going to be redone as shown. The owner can spend $420 or less. In other words, or less imply that this is going to be an inequality. Write a linear inequality and graph the solutions. What are 3 possible prices for the wallpaper and tiles? Now, as you can see, behind the counter there's wallpaper, and you need 3 feet by 8 feet of wallpaper to make a total of 24 square feet. The tile area goes over the stove, and it's 3 feet by 4 feet for a total of 12 feet. So since we already know the dimensions, we don't need to worry about the length and the width, or length and height, however you want to call it. Let's just worry about what the total is. 24 and 12. Those are the 2 numbers that we really need. So to put this in a linear inequality, we would have to come up with variables. So x, let that be the paper, which would be over here, the stove, and y be the cost of the tiles, which is over the stove. I think I said stove twice. I meant over the counter for the paper and over the stove for the tile. Okay, and if you can see here that it's actually been put on a graph. So here's how we get this into slope-intercept form. So the total cost is $420 or less. So we write this as 24 times x, 24, x meaning the paper, plus 12 times y, the cost of the tile, is less than or equal to 420. And we use less than or equal to because the original problem said $420 or less. Okay, so that kind of gives us a range. So then we want to subtract 24x from both sides so that we can get the y isolated and get it into slope-intercept form. However, the y is not totally isolated, so we have to divide both sides by 12, and we end up with y is equal to negative 2x plus 35. Okay. Now remember, it's negative because we subtracted 24x from both sides. So from this side you get 0x, and from this side you get minus 24x, which ends up being negative 24x. Okay, so now that's in slope-intercept form. Y is less than or equal to negative 2x plus 35. I want to note that the inequality stays the same because we did not multiply or divide a negative. We subtracted a number and it became negative through subtraction, but it did not actually change the sign. Okay, so addition and subtraction do not change the sign, multiplication and division do. So then we want to graph the inequality. So you end up graphing the line here. Now you'll notice we only use quadrant 1 because in this case we're not going to have negative values. Now a negative value for the amount of money that you spend on tile or paper could be equated to like the store paying you money to take their paper or tile. And there's no like furniture store or like supply store that's going to do that. That's just not going to happen. Okay, so negative values wouldn't make sense in this particular inequality. So let me just try to focus in on the graph because that's the main thing I kind of wanted to look at now. So we have the cost of the tile here and the cost of the paper here. Okay. So one thing I wanted to see, the more that we pay for the tile, the less that we can pay for the paper. The more that we pay for the paper, the less that we can pay for the tile. Okay? So like for example, if the tile costs $20 per square foot, then that would put me right here. But then that means that the paper costs really can't go like above 5. And if I wanted to spend $15 on the paper, try not to mark in my book here, then the most I could pay for the tile would be $5. Okay, so that's what that line shows. Anywhere that you would put an ordered pair in the yellow could represent the cost of both items. Like on this corner here, I would have $5 for paper and $10 for tile. So that would obviously be less than. As it gets close to the border, that's where you end up with it costing exactly $420. So if I had $5 per paper and $25 per tile, then that amount here would be would end up costing the full amount. Okay. Now let me go to the next problem, and you can see why I chose to just show you the book on these problems. And the reason is because with all of the graphs and like the words to write and stuff, it's not going to be very easy. And I don't know that it's going to be any easier for you to learn it if I write it myself. Okay, problem 5 here, and this is on page 422. It says write an inequality from a graph. Multiple choice. Which inequality represents the graph at the right? I'll read them. Y is less than or equal to 2x plus 1. Y is less than or equal to x plus 1. Y is greater than or equal to 2x plus 1. Y is less than 2x plus 1. Okay, so let's take a look at the graph here. In the graph, we have a shaded side and we have a solid line. So a solid line indicates that it is a, yes, Esau, that's right, a closed inequality. Okay, so let's take a look. I have a closed for A, I have a closed for B, and I have a closed for C, but I have an open for D. So we know that D cannot be it. I'm obviously not going to write in my book and cross that out. But D can't be it because um, we have a closed inequality and a closed line. Okay, now let's take a look. Above, the inequality is not shaded, so that means any points here would be untrue. It is shaded below the line, okay? So if it's shaded below the line, then that would indicate if it's in slope-intercept form, then y is going to be less than or equal to. So let's take a look. C says y is greater than or equal to, but these other ones say y is less than or equal to. So it cannot be C because it has to be less than, because if y is less than in slope-intercept form, then we shade below the line. I don't care that the line has a really steep slant. You can still tell that this side is above and this side is below. Okay, so now all we need to do is figure out the rest of it. Okay, so I see in slope-intercept form, then +1 means that my y-intercept is +1. So they both have +1, and that means, yeah, I couldn't tell it just from that. So then let's take a look at the slope of each. So the slope here for B would be 1 over 1 because there's nothing in front of x, which implies that it is 1. So if I go 1 up, 1 over, 1 up, 1 over, 1 up. Now let's take a look at the slope here. It would be 2 over 1. So I would go 2 up, 1 over, 2 up, 1 over. Looks like it's going to be A, okay, because that matches the slope. Okay, hope you were able to understand how we got those numbers. One last thing, I made up my own equation here, or inequality rather, not equation, and I thought we could graph this, okay? So in this one, it is y is less than 2x plus 5, okay? It's 2x minus 5, regardless, sorry. So on this one, I'm going to start by graphing my y-intercept. So it's -5, so I go 1, 2, 3, 4, 5, down. There's my first point. Okay. Now I'm going to use the slope to determine the next point. The slope is 2x, so that would be 2 over 1 times x, so whatever the value of x is. So I'm going to go 2 up, 1, 2, and 1 over. There's my next point. 2 up, 1, 2, and 1 over. Okay, so now I've got a line. So let me grab my ruler here, and I'll go ahead and I'll make the line. However, I have to determine, is this going to be dotted or dashed? So this is an open inequality. Solid or dashed. So I make it a dashed line because it's open. It's open line, open inequality. Now the last thing I need to determine is, do I shade the bottom or the top of the line? Now in the last lesson, we said that you can do a test point, but in this lesson, we're going to do it by the inequality. So it says y is less than. So if y is less than, then we shade below the line. Okay, I hope that makes it clear. And we can always do a test point just to make sure we got it right. So the point 0, 0 is right here in the middle. I'm going to substitute 0 in for x and y. 2 times 0 is 0. 0 minus 5 would be -5. Is 0 less than -5? The answer is no. So, and we can say I did not shade the side that has 0, 0 in it. So good, we've tested it, checked it, and finished it. Thank you much.